Hey guys, Blake here. Today I wanted to demonstrate Linux on the original x86. In our case, it's going to be a 16-bit Intel 8088, which is the 8-bit external bus version of an Intel 8086. It's going to be inside this IBM 5155, with the only addition being a PicoMem ISA card. That's going to bring our system memory up to 512 kilobytes. It's going to emulate an IDE hard drive for our image to be a little nicer and easier. And then it's going to emulate an NE2000 network card to demonstrate some of the networking capabilities. For software, we're going to be using ELKS, or the Embeddable Linux Kernel Subset. So this is the most recent build of ELKS as of this morning. That was the last commit. It's your standard Unix-esque environment. We can log in as root. That's the only user I've made on this. It's a true multi-user Unix-esque system, Linux in our case. It has screen, and I'll show you some other networking stuff later, but you can have multiple terminals or users. Something worth pointing out, it's said that you only need 128 kilobytes of memory to boot. I haven't necessarily had an image that boots in that size. I probably could, but the image I have as it's running only uses 83 kilobytes of memory, which is pretty nice. You can do all kinds of different optimizations with ELKS. You can use Busy ELKS, which is basically BusyBox for ELKS. There's all kinds of kernel options you can do to, tweak your image to your liking. If you need a smaller image to fit on floppy, if you need to use less memory, if you want more memory for more features, all kinds of stuff. Our base directory is the usual, pretty standard. If we look at bin, we got kind of a peek at most of the binaries and functions we can use on this system. We take a look at our devices. Pretty standard stuff. As you'd expect for a system of this era, we got our floppy drives, which is nice. But you can use this system and its hardware just as intended. Another thing I'd like to show you guys is a C toolchain I've built for this system. On GitHub it's called the 8086 toolchain, and you can build it alongside ELKS effectively. It depends on OpenWatcom v2. I think it also uses i16 ELF GCC. But either way, it's built for this system, and it provides make, C preprocessor, a compiler, an assembler, and a linker. So that's convenient. You can see here we got some demos that came with that in a make file for them. So I'm going to compile one of or build one of these just as an example. We'll build chess. As you can imagine, on a 16-bit Intel from the 80s is going to take a while, even though it's a relatively small program. Alrighty. Not so bad for 16 bits at 4.77 megahertz, I'd say. Let's see what our result is. There we go. I'm not going to play a whole round of chess here, but I'd say that looks pretty good. The next thing I'd like to show you guys is the networking features. For that, I'm going to have to start our networking stack. This is going to end up hosting a telnet server and an FTP server, but I will not be connecting to those with another machine as of this video. I have done it though, it does work. It's really slow. I mean, I don't know, it's not that slow, but it's not your average everyday SSH or telnet experience. Awesome. So let's connect to our server. Look at that. So yeah, now we're in my mainframe. But this is useful. You can do anything else from that system and that system has. In our case, I will just show you guys this little script I made that does some fancy graphics through Figlet. I haven't ported much of anything, including that, to this system natively yet, so we'll run it off our server. Oh, I forgot. Look at that. Got a little messed up. I guess I needed to scroll. There you go. Well, that's about it for this little demonstration. Thank you guys so much for watching. I hope you enjoyed it. This doesn't seem to be... There you go. So yeah. Thank you guys.